Thank you, Brett. Everyone hear me okay? All right. Good job, everybody before me. Thank you, Brett. Thank you for everyone for coming here. Sorry, it's hard to see. You got to look all the way up in here.
You can look there, too.
I'm going to look here. Yeah. That's what I'm going to do. Otherwise, I'm floating all over the place. My name is Mike Schaefer. I'm the Performance Instruction Manager for Mitsubishi for our central business unit, which is the Midwest. So I live in the northwest suburbs of Chicago. So I drove over this way today, and I cover 12 states here in the Midwest, from the Dakotas pretty much over to Ohio, West Virginia. So my main focus is new construction, as well as renovations, rehabs, just really looking at it from a residential as well as a multifamily aspect. Also here from Mitsubishi is this handsome gentleman over in the corner, Mr. Ryan Spangler, and he's the area sales manager here for Western Michigan. So he's actually the local contact for you as well. Brett did a really good job of laying out electrification and everything that we're here to talk about tonight. I had a lot of slides based on electrification. I'm glad I took them out because it would have been just very redundant for what he said. But my main goal is, from a new construction or renovation standpoint, is to utilize electric forms of heating in these homes or in these multifamily units. If they have gas, it's also looking to potentially just displace that energy as well. Maybe not eliminate gas, because I work in a lot of colder climates, colder than here. When you get up northern Minnesota and Dakotas, where gas is still pretty much essential for that, okay, maybe we can just displace some of that energy usage as well from the gas standpoint. But whether it's through air source heat pumps or ground source heat pumps or air to water like the Chiltrex system, just some way of getting that home electrified. That's my main purpose. So what we're going to talk about real briefly, because I only have 15 minutes and I'm the one that's going to keep us on track for not going over this entire night now, is mainly talking about technology, efficiency, cold weather capability, some design and application of air source heat pumps, giving you kind of a broad overview of what they are. There's a lot of folders on the tables out here. I had no idea, especially when I agreed to pay for the first beer for everybody, the amount of people that we were going to have here, because this is way more than what I expected, but it's fantastic to see a room full of crazy people like me here that want to try to electrify things. But there are folders on the tables. If you need more information, please let Ryan or I know. We can get you more catalogs and more folders as well too. First off, kind of the lifeblood of an air source heat pump, or for Mitsubishi in particular, is our inverter compressor. If anyone's familiar with a traditional compressor, that's when we're talking about a traditional unitary type air conditioner or heat pump. Usually is a single stage type compressor, kind of an on-off system. How that works is, when the system turns on, that compressor pretty much ramps up to about 60 hertz. Takes a little bit of time to drop that temperature, usually a couple degrees below set point. If you look at it from a cooling, if we're looking at it from a cooling standpoint, drop the temperature about a couple degrees below set point, and then what does it do? It kicks off. That's pretty much standard, right? And then when does it kick back on again? When you get a couple degrees above set point and you're starting to get uncomfortable, that system kicks back on again. And then what does it do? Satisfies the temperature, kicks back off. It's that on and off function of how it actually works. So if you're used in your house, if you live in an older house or have a traditional system, you see dimming of lights when the air conditioner kicks on. That's that compressor banging on and banging off all the time. High energy use, very uncomfortable in terms of temperature swings in the home, but that's kind of what we're used to a lot of times, so people don't think it's that odd. But there's a better way to do it. An inverter compressor is the way to do it. So all of Mitsubishi systems and air source heat pumps in general have inverter compressor systems in them. So if we think of an inverter compressor, it's more like a modulating or a variable speed type system if you're used to it. So how our compressor kicks on is it starts a very slow start, a soft start. It doesn't bang on like a traditional system. And then it ramps up very fast. So high rotation speed is going to drop that temperature very quickly to set point, and then we're just going to maintain. And that's all we're going to do. We're going to drop down and run around 30 hertz, and we're just going to maintain. So we're going to keep that temperature consistent in the space. We're not banging on. We're not banging off. It's like when you pump your gas, you get on the on ramp or the off on ramp, and then you get on the highway and you just hit the cruise control button. And then we're just maintaining. So that's how the inverter compressor works. A lot more comfortable in terms of temperature in the home, a lot more energy efficient. When we think of air source heat pumps or a Mitsubishi system, we generally think of ductless, which is the wall mount unit. So if you're used to hearing like a mini split or a ductless system, that's the type of system that we think of, is that wall mount unit. As we can see here, there are a multitude of different options. We have single zone systems. Single zone systems meaning that there is one air source heat pump sitting outside that is connected then to one of these indoor units inside as well. So that's a single zone system. Then we also have multi-zone systems where we have one outdoor heat pump connected to a multitude of indoor units. From 2 up to 8, you get into commercial up to 50, so a lot more when you get to that. So we have wall mount units, floor mount units. We have units that we can put ductwork on. You know, we say ductless, but I'm not anti-ductwork. We have indoor units that you can utilize ductwork with as well. I'm pro ductwork as long as we keep it controlled, sealed, and tight. We have ceiling recessed. We have a couple new units, like our multi-position air handler. So if you have a home that's being built and they say, I don't want to see any of this stuff in my ceiling, on my wall, on my floor, I just don't want to do that, I want a traditional system, we have multi-position air handlers that are literally installed just like a traditional furnace is or a traditional air handler. It's utilizing that inverter system. It's utilizing hyperheat cold climate technology, which we'll talk about, but it's going to look just like a traditional system, and it's going to be ducted just like a traditional system. We also have our newest unit, which is a one-way ceiling cassette. The beauty of this unit is that it's built to fit right in on 16 on center joist spacing. So you don't have to have any form of special access panel. You don't have to do any kind of framing in your joist to get a ductless system in. So this gives you the option of going, I want to eliminate ductwork. I don't want to use it, but I don't want to put anything on the wall. So I'm going to use a system that I can retrofit very easily or in a new construction aspect, put in without a lot of other framing work. All of these indoor units combine into what we call is zone comfort solutions, and that's really precise temperature control, precise energy efficiency, giving you the exact temperature and control in each space in your home that you want. So I talked about our hyperheating. I mentioned our hyperheating technology. This is our cold climate heat pump technology. So why have traditional heat pumps not been used as a primary form of heating in colder climates? They can't do it, right? They can't do it. So a traditional heat pump, like the standard on the chart here, we have those as well that we utilize in warmer climates where people really want cooling and may have a little bit of heating. A standard heat pump, once you hit that 40-degree temperature or so, your capacity just dives off. It can't be a primary source of heat in a cold climate. With our hyperheating technology, that has changed things drastically. So how our hyperheating technology works is there's a lot of stuff going on in a compressor that we can talk about later and do things offline. We don't have time for that. But it maintains higher heating performance to much colder temperatures, as you can see. Our hyperheat technology maintains 100% heating capacity all the way down to 5 degrees. So at 5 degrees, you're getting out of that air source heat pump what you're getting out of it at 47 degrees. And then at 5 degrees, that's where we start to derate. But as you can see from this chart, it's a much slower derate. We have systems that are maintaining 93% capacity still at minus 13 degrees outside. And that's air temperature. That's ambient temperature. That's not wind chill. Wind chill doesn't matter for us. So think about how often you are minus 13 degrees here, air temperature, not wind chill. Not very often, right? So question, what happens below minus 13 degrees? Does anyone know? If you need it. So our systems don't turn off at minus 13. That's just where for AHRI purposes we rate them at. So they continue to operate and that chart just keeps going on the same scale that it's going on. So our systems don't stop operating at minus 13. If you are in a much colder climate, like a Minnesota or other areas where we do have a lot harsher temperatures, then maybe some backup heat is required if you look at that. So let's look at Grand Rapids because that's where we are. So we want to focus on what is our actual bin data heating hours here in Grand Rapids. I said, I'm from Chicago. It's a lot colder. You think it's colder today. It was like 8 degrees when I left this morning to drive over here. So it was a lot colder over there than it is here. And I have a lot of new construction as well as renovation projects in Chicago that there is no backup heat in at all. And that's been years now with no problems on that. But if we look at Grand Rapids in general, this line right on this chart here is that 5-degree line. Remember, we operate just fine below 5 degrees, but this is where we're 100% capacity. This little lip right here is the amount of time we're actually below 5 degrees here in Grand Rapids. It's not very much. I dug a little bit deeper. This is a 20-year weather history from 96 to 2016. There's some websites you can grab this off of. I can grab it for anywhere if you wanted to know. But this shows the total bin data heating hours and cooling hours for Grand Rapids. This is the below 5 degrees area. It's 122 hours on average every year we're below 5 degrees here in Grand Rapids, which equates to about 5 days, that we're actually below that 100% heating capacity time. Can we handle it below 5 degrees? Absolutely we can, as long as we size things appropriately. But a lot of times in cold climates, we get that mindset of it's just too cold for an air source heat pump. Traditionally, it absolutely is. But with newer technology and ways of size and design, it can absolutely work. So that's just Grand Rapids in general. I want to show a little bit here on energy. Sorry, that founders thing was supposed to be on the previous one, which you get the founders one because you answered the minus 13. For sure. Sorry, that thing was supposed to be on the previous slide. That's okay. You got it. I want to talk about some energy efficiency here because we have a lot of people here from the utility side. Our utilities manager ran some scenarios here looking at AHRI data of what products and what are their energy efficiencies out there. He used the 16 SEER 9 HSPF as a baseline. So in the AHRI directory, there's over 387,000 active heat pumps. That's your traditional unitary heat pumps active in the AHRI directory. So like a Carrier or a Lennox, those type of traditional systems. Out of those, only 13% actually meet that baseline that we consider to be above that high efficiency. If we looked at variable speed ductless heat pumps, there's a lot less. There's only 6,000 of them listed in the AHRI directory, but 79% of those meet that high efficiency threshold there. If we look at the Mitsubishi equipment a little bit more in depth, this is our total product line here. Almost all of our products meet that 16 SEER 9-point HSPF. If we look here, we have systems above 30 SEER. We have systems that are 33.1 SEER, 31 SEER, 30 SEER. So we have very, very energy efficient products with high HSPFs as well, with higher COPs. So we're not just efficient on the cooling, we're efficient on the heating as well too, because that's a very big misconception of electric heat, right? Think electric heat, you think electric resistance heat, which is 100% efficient, but costs an arm and a leg to run. So we're a lot more efficient than electric resistance heat. For the sake of time, I'm not gonna dig into this, but Kevin, our utilities manager, put this together too. He used 10.53 cents of a kilowatt hour, looked at all these different efficiencies utilizing cost per million BTUs. We're the red, we're COPs. As you know, air source heat pumps, since we run off of the air, we're pulling heat out of the air. The colder it gets, our COP does go down from that aspect because it's an air source heat pump, but we run on average between 2 and 5. It isn't until about 5 degrees that natural gas starts to become more efficient in terms of cost per million BTUs. And remember, how many hours here are we below 5 degrees? 122. Everyone gets a beer. Everyone got a beer already. 122 hours. So only 5 days of the year does that actually equate to natural gas being more efficient than our hyperheat heat pump at that time. I don't know how we are on time here, but I'm going to burn through this. So I said my focus is new construction. What we focus on is comfort, health, and efficiency. Code compliance is driving a lot of that, though. As we know now, Michigan's what, 2015 IECC code? So code is driving a lot of the things that we're out there preaching already. As we know, as the code gets, as the codes progress, it gets stricter and stricter. Brett already mentioned it. Heating and cooling loads get lower and lower. Big reduction in energy usage with 2015 IECC, increased envelope tightness, additional regulations on ductwork. So we have to seal, we have to test ductwork. So going ductless saves a lot of money, saves a lot of time of testing and sealing ductwork. Increased ventilations and indoor air quality requirements. The housing landscape's changing, obviously, we know that. So we're a really good solution for that. Air source heat pumps are a really good solution. Whether it's ductless, whether it's all ducted with our multi-position air handler or horizontal ducted units or whether it's a mix. I like a mix. I like a ducted ductless solution a lot. I really like that. So we can design in a multitude of ways. For the sake of time, I'm just going to focus on a couple things here. These are just some pictures. There's a floor mounted unit. There's a wall mounted unit. Here are some instances of our horizontal ducted units installed in new construction. The key is keeping it inside the thermal envelope. That's the key with ductwork. Like I said, I'm not anti-ductwork, but let's make sure we keep that ductwork inside the thermal envelope. Let's keep it tight, and let's keep it sealed and clean. So this is our horizontal ducted units actually installed from soffitting. So soffitting is a way to do it. Has anyone used a plenum truss design, a modified truss design? That's where you can raise the truss in the plenum and put your horizontal ducted unit and ductwork right in the center, kind of building a cavity for that system and keeping it inside the thermal envelope, where you don't have to seal off your attic. You don't have to worry about fully encapsulating that attic if you keep the ductwork out of there. Compact duct design is another thing. We can talk about that offline for the sake of time as well. So how do we design right when we build so tight? There's a couple ways. I said I really like that hybrid ductless ducted design. I mean, think about how do you install an air source heat pump with a multi-position air handler? Very easily, the same way that you would install a traditional system. So how do you do it with ducted and ductless equipment? Here is just an example. There's a multitude of different ways that we can design homes, whether it be new construction or retrofit. But let's take this standard ranch model, and let's say the homeowner wants to put this into 4 zones. I'm going to have a multi-zone outdoor unit, and I'm going to put a ductless indoor unit in these 2 bedrooms. No ductwork. I'm just connecting with copper line sets to the air source heat pump outside. But then I want to zone off a couple other places in this home too, but it's too closed off to really use all ductless in there. I don't want to put 6 different ductless units in this house, so let's utilize a little bit of ductwork. So let's put some ductless units in these 2 bedrooms and then use some horizontal slim ducted units to take care of this living and kitchen area. And then I want my master on a zone too, so I'm going to put that on a very small ducted system as well. So what did I do with this house? I'm able to utilize air source heat pumps. I'm able to do ducted systems for these larger areas and for my master. And I can do ductless systems for these 2 smaller bedrooms. And now I have 4 individual comfort zones in this house. So if I want to set back this unit when I go to bed because nobody's in this room, I can. If I want to turn it off, I can as well. If I want to have a colder temperature in my master bedroom when I go to sleep at night, that's what I can do, and all saving energy and being comfortable at the same time. We're here, Brett talked, electrification. There's all these reasons why. We're all interested in this for whatever reason it might be, but we know that either displacing the fossil usage of fossil fuels, going towards all electric, we know it's the way we have to go to help our climate, to help our planet. I talk about this, and in some areas you're crazy. We can't do all electric heating. We can't do all electric cooking. We got these great things we'll talk about. We can't do all electric water heating. It just doesn't make sense. It costs too much money. You're nuts. You're crazy. We hear that all the time. I found this quote. This quote really, I think everyone can probably relate to that. It's the ones who are crazy enough to think they can change the world are the ones that do. So sometimes it takes a little bit of crazy thought to think, well, maybe I can do my heating. Maybe I can do my cooking. Maybe I can do my water heating, my clothes drying, everything all electric. We definitely can. There's a lot of things we have to keep in mind, and that's designing appropriately. That's what I can help with. That's what Ryan can help with. That's what we can do from a heating side, is if you have a retrofit, if you have a new construction, it's all about designing it appropriately. I've seen our equipment and applications that is working fine, but the design is terrible. And then it isn't working okay. Like the equipment's fine, but the homeowner's not satisfied because the design is not right. So I want to make sure with every home that I'm involved in, every multifamily that I'm involved in, that we're doing the right design, because that means more than anything. So the goal obviously then is to build better. So in order to change the world, we have to tackle this water heating, we have to tackle this space heating, and we have to build better to do it. My contact info, as well as Ryan, please reach out to either of us if you have any questions. We're here to help. Like I said, I'm out of Chicago, but I cover the whole Midwest. Ryan's local here, so we can help with any kind of questions you might have. If you want more information, we can always meet with you at another time as well to dig a whole lot deeper into what I covered here in hopefully 15 minutes. I have no idea how long I went, but that's all from me. Thank you.